Hello, this lesson is a homework guide for week 3 and week 4 homework. And this is about how do I, what do I expect when you do your homework? Okay, I wish you to understand that the centerpiece of this course is about these concept definition, right? We've mentioned this over and over again. Definition is number one important thing that we keep on reflecting on the definition. And also for trigonometry functions, right? The stage set and the ARD, right? The A, the R, and the D, right? Here we only have the definition of sine. And of course, if you cosine, tangent, cotangent, cosecant, secant, right? So these are the centerpieces. So when you're doing your homework, I would like you to reflect on these concepts and think about the definition, how the definition is being used, right? How the angle is measured, how reference angle is defined, and how we actually find the reference angle, and the definition and definition. And of course, we have 6 definitions, right? On these definitions, right? The input are the angles. The type of quantity it's measured here. It's an arc length. It's a radian, or it can also be degrees, right? And it's going to be the ratio. So it doesn't matter what kind of what type, right? Whether degree, radian, or arc length, they all mean the same thing. Arc length of unit circle, right? And the output are all ratio. Okay, so that's the emphasis here. The output are all ratios, whether it's sine, cosine, tangent, cotangent, cosecant, secant, right? Input is a specific type and output is another type. Okay, so this is really we want to make sure that you understand. Okay, so we repetitively focus on these concepts. So when you do your homework, and this process should reflect, right? But how do I measure you've done that, right? How do I measure you have done that? Well, I think in time, if you keep doing this, right? If you keep doing the 3 pillars of trigonometry, it will be reflected. It will be reflected from your work. It will, okay? Especially when you're not dealing with special angles, right? When you're dealing with special angles, I know many of you some of you have a way to do it. You just have a great memory. You remember the unit circle. But I insist that you still focus on the definition, okay? We understand how from the definition we have constructed the unit circle, right? We constructed this unit circle ourselves and we drew the sine curve. We haven't done, we haven't done the other curve yet, okay? But we will get there, we will get there. And we already have shown the method of doing so, So this is going to be, so today I'm going to show you how I would like you to do your homework. Okay, take some examples, take some homework questions from week 3. Okay, so right now I'm looking at Canvas week 3 on the trig function part, right? For example, if you see the first question, number 5, right? Number 5, I have 1, 2, 3, 4, 5, 6, right? And I told you to find the values, right? I was asking you to compare, right? And of course, we asked you to give the answer in rationalized denominator form. So this intention, right? 1, 2 is for us to observe if it's odd function, even function. If you look at the lectures we have, is that it's a process of discovery. okay? But when you do it by definition, okay, so I'm going to show you an example, right? Number one, right? Number one, we want you to find sine of pi over 6, right? Everybody know the answer of sine pi over 6, right? Number two, maybe I can just make a table like that, right? So sine pi over 6, this is a pair, okay? And this is the other pair, right? Sine of negative pi over 6, right? So I have another pair. So that's 1 and 2, right? That's 1 and 2. So I'm going to mark it as 1 and 2, right? So this is 1. And this is 2. The intention of giving you a question like this, right? If you work on the unit circle, I actually would like you to look at both ways, right? You look at both ways, and then you see that pi over 6 is a positive angle, right? So you would measure counterclockwise. Hold on. I made a curve there, okay? We would do counterclockwise. Okay, it's a counterclockwise measurement. So you terminate over here, right? And for negative pi over 6, right, you measure from the standard position and negative pi over 6. I want these thoughts to go through your mind. How do I assess you? I don't really know, because I cannot be a bug in your mind, right? But I can only show you that if you do this, it's going to enhance your ability and you have a deeper understanding of the definition and the 3 pillars. Overall, only the 3 pillars will be of usage to us if you ever use anything trigonometry, okay, in the future. So with that said and done, right? And then you have this arc length, right? Arc length. So I wish you to make that a connection, right? This is arc length, right? And this is another arc length, right? That's another arc length. And these arc lengths were, they're going to be, this is pi over 6, and this is a negative pi over 6. So all that story, all that narrative, right? And this is the blue number, which is, we pick a point on the terminal size of the angle, and the point is arbitrarily chosen, and we choose the points to be on the unit circle. So we get these 2 points, right? So we're really citing the definition, and we're reflecting on definition. And here the blue dots, this is positive, this is negative. So not only you see those numbers, you have a visual. In fact, you actually don't need to know the value. You actually don't need to know the actual value. You know that when the inputs are opposite, negative pi over 6, and negative pi over 6 and pi over 6, they're opposite, and their output is also opposite. Okay, their output is also opposite. Okay, so you can do that, right? And the other thing is you will realize, just play with these numbers, right? This is going to be negative of sine pi over 6, right? So this is a fitting for one case of odd function, So you continue to do that for sine pi over 4, sine negative pi over 4, sine pi over 3, and sine negative pi over 3. Okay, so here, let me give you another example, right? The second box, right? The second one. And this pair would be, you see, this is how I wish you to do the homework. Okay, this is how I wish you to do the homework. And if you do this, okay, you will eventually be the master of the subject. Okay, so the next one, the next group I'm going to show you, and this is also in the homework. This set is what is it? Okay, so what I'm going to do is I'm going to take this whole thing and put it beneath it, right, underneath it. So this way, when I need to use them, they're right there, right? Reflecting on the three pillars, reflecting on the three pillars. So this time the question will be 3 pi over 4. Okay, and this is a negative 3 pi over 4. Okay, what do I wish for you to do? 3 pi over 4. And that's, we measure the angles, right? From the standard position for 3 pi over 4, that's counterclockwise measurement. You ended up here. This is a terminal. And you pick the point on the unit circle where the unit circles cross the terminal, okay? And the negative 3 pi over 4, and we're still measured from the same position, but clockwise. You see, we are reflecting on that definition, right? And if you ask reference angles, of course, we have reference angles. There's reference angles here, which is pi over 4. And this is also reference angle. They have the same reference angle, right? 2 pillars already. Definition is they're equals to y, right? And then you look at these two values. Right? The input, 3 pi over 4. Where do you find the input of 3 pi over 4? Well, it's the arc length. It's the arc length. This is the arc length for 3 pi over 4. Negative 3 pi over 4, and this is the arc length. If you understand this and you keep doing this, it's going to be part of your knowledge, and it's very intuitive, and you will find it helping you when you are doing calculus class. Okay, so the arc length. Now we have 2 terminals, 2 angles measured, in the angle measurement way, and the 2 blue numbers. Okay, this one, right? This blue numbers, that's a sine value, and there's another sine value. They're opposite to each other, right? So they're opposite to each other. So once again, you can have something like this, right? Sine of negative 3 pi over 4 is equals to negative sine 3 pi over 4, right? So the odd function definition is more concrete to us. And now let's go to the curve. What's happening on the curve, right? On the curve, the 3 pi over 4 is going to be on this side. Okay, let me make it thicker, right? It's going to be on this side. 3 pi over 4, right? Passes pi over 2, right? So 3 pi over 4 is going to be somewhere here, right? Negative 3 pi over 4 is going to be right there. You see, they're opposite. One is positive, the other one is negative. Or this one is negative, it's opposite, it's positive. And the blue, okay, and the blue right there. And that's the ratio of positive root 2 over 2 and negative root 2 over 2. So when the inputs are opposites, their outputs are opposite as well. So this identity demonstrates that this function is odd. So that's the intention. I put together the question. Okay. There are other questions which are cosine, right? Tangent, cotangent. We haven't done the curve for those functions yet. But can you do it? Of course you can, right? Of course you can, because you just need to understand. Because we did that as a case for 3, 4, 5, right? So all of these can be done. Okay, so let's pick an example for cosine. Let's pick up an example for cosine, right? How would you do this, right? We are going to do cosine curve overall, right? So I'm going to, of course, the sine curve is not going to be useful here now. So I'm going to just work on cosine from the perspective of definition, right? We still have the three pillars, and cosine tell us, right? Cosine is what kind of function? So I'm still going, because we're dealing with special angles, right? So special terminals. So what I'm going to do is that I have this with me, and I also have the three pillars in my head, right? The three pillars, okay? Standard position, right? And ARD, right? ARD, angle measurement, reference angle definition. Since this is a cosine takes the input, it produces, the input is going to be angle, right? Angle, we want to make a distinction. And our cosine is cosine of the angle, right? Cosine of the angle produces an output. Right? This output is, if it's on the unit circle, if the point is on the unit circle, is going to be x over r. And because it's on unit circle, r is 1, therefore it's just x, right? So it's the red number. It's a red number, right? So for example, if I would do, I would do this example, right? I would do the next one. I would do this example. I'm taking an example from our homework. Okay, so you guys just look at your homework on Canvas. Okay, and the first question I would try is cosine pi over 3. Okay, cosine pi over 3. Hold on, why did I click that? Okay, cosine pi over 3. Okay, and a cosine negative pi over 3. So before we actually draw the curve, draw the whole curve of cosine, I know many of you already know this, right? We already know some values because we can get those values by definition, right? We can get those values by definition. So cosine pi over 3. So how do we get that? Pi over 3 is an angle measured. Okay, and counterclockwise. Too thick. Okay, too thick. All right, so measure that counterclockwise, pi over 3 right here. So that's a terminal, right? And the point we chosen arbitrarily on the terminal sides of the angle, so that's the point, right? And the other angle, negative pi over 3, is going to be measured from the standard position and terminates here. You see, we're having the same narrative, and this narrative is all about that. It's about, you know, angle measurement, reference angle, and definition, really. Okay, and so this is a positive pi over 3, and the other one is negative pi over 3, right? So we get a terminal, and we got the points on the terminal, also on the unit circle. And so this is going to be pretty straightforward, right? It's pretty straightforward. What do we find? The red numbers are the same. Okay, so this equals to half. And this other one is also equals to half. Interesting, right? What have we found? Cosine of negative pi over 3 is the same as a cosine pi over 3. Okay, and we can do a similar example. So I'm going to do it on the same row. Right? So how about 2 others? And this already tells us some information, right? So this is going to be a 3 pi over 4, right? Negative 3 pi over 4. And of course, the value is no longer half, right? What do we see? Well, we're going to measure, right? We're going to measure, right? 3 pi over 4. I'm sure when you do it, you're going to do faster than, than my speaking it, right? Positive 3 pi over 4, that's a terminal, that's a point on the terminal. And the negative 3 pi over 4 measured from standard position, and it, it also terminates, right? Also terminates, start from the standard position, terminates on this terminal here because angle measurement, right? And then you look at the two ratios, the two red ratios, because we look at the red number, right? Because the cosine of that angle is A on the unit circle. So what do we see? Right? We see negative root 2 over 2 right here, right? Negative root 2 over 2. And we also see another negative root 2 over 2. So they're the same value. They're the same value, right? So now, then you start to think, is that always the case? It seems, right? And then this is going to be equals to negative, right? Root 2 over 2. Okay. And this other one is also negative root 2 over 2. See, we're really just using definition. We're really just using definition. Okay. And so this piece, right? This piece will get us to know what? Cosine of negative 3 pi over 4 is the same as cosine 3 pi over 4. Okay, so that's our context. That's our context. Yes, a little bit. Oh, oops. Okay. Maybe 100. Anyway, so this is okay. Doesn't that remind us of even function definition? Of course, these two just verify it. So it seems that cosine might be. So you'll be guessing, right? Cosine might be an even function. Cosine might be an even function. And when we are doing the graph of the cosine, you will see that you're going to see we're going to be doing similar things, right? So we can actually discover that. We don't have to wait until we have done the entire curve of cosine. We can, if we are being mindful, right? We are clear about these concepts, and we're seeking to apply these concepts, right? So what are these concepts? One-to-one function, increasing function, decreasing function, and what else? Even function, odd function. Even we are mindful of these concepts, you start to apply them. So that's what I hope for. Right? Now, well, we haven't drawn tangent, right? Of course, but we can still use definition. Okay, so next I'm going to clean up and let's look at some numbers that's in tangent. That's in the tangent case, right? In the tangent case. So once again, I'm going to bring of course, if you draw your tangent curve and on your, I'm not against it. That's okay, right? So what are we going to see is that we're going to see tangent pi over 6. Tangent pi over 6, right? So tangent pi over 6. Okay, wait a second. We're going to do pairs, right? We're going to do pairs. So tangent pi over 6. Oops. How did that happen? Cut, put it here. Okay. And tangent negative pi over 6, right? Opposite input. And so this is number 1, number 2. Okay. So I'm going to compare these two numbers. What will happen? Well, how do we combine? By using definition, right? Because cosine definition, right? So let me introduce a cosine definition or review cosine definition. It's an angle. It produces a ratio. And what is that ratio? This ratio, right? You find the terminal, you pick a point on the terminal side of the angle, right? So that ratio is going to be y over x. So tangent A is going to equals to, right? The blue number are y's, the red number are x's. So it's y over x. Y over x. In other words, it's really what? It's really the blue number divided by the red number, right? So we can do it without having to see those curves. And this is preparing us for when we are doing the curve, we're ready, okay? So with that said and done, and then we're gonna use a definition about angle, right? So we're gonna measure the angle from standard position, right? Pi over 6, we get to here. Negative pi over 6, and we will get to be over here, right? So one is a pi over 6, and the other one is negative pi over 6. With this setup, what do we see? We see two pairs of blue numbers, two pairs of red, blue, right? Red, blue, okay? Now, what do we do? By definition, of course, their reference angles are also the same, pi over 6, right? So tangent pi over 6 is going to be the blue number divided by the red number. The blue number is half. Okay, the red number is √3 over 2. You see? Okay, √3 over 2. And the other one, right here, is going to be blue number is negative half. Okay, whoops, negative half. And so I should make the fonts a bit larger. Okay, so that way you can see the number better. Okay, 175%. Okay, negative half over √3 over 2. So so what do we see here, right? So we're gonna get on the top, we're gonna have 1 over √3. And what do we get for the bottom? We're gonna get negative 1 over √3. They're opposite. And of course, we ask you to rationalize it. You multiply √3 with √3, right? You multiply √3 over √3. Right? And then you're gonna get √3 over 3. The other one is about the same procedure. It's just negative. So you're gonna get negative √3 over 3. So what do we see? When inputs are opposite, their respective outputs are opposite too, right? So tangent of negative pi over 6, right? So let me see if I can put it here, right? Is equals to negative tangent pi over 6. Odd function, most likely. Odd function, most likely. Of course, this is not a proof. Okay, this is just a verification, or I call it discovery. Okay, we will discuss these, but before we get to there in the future weeks, we already have a glimpse of it. And these examples will be very helpful for us, and when we get there, right, and covering these concepts, right? So that's for tangent. Cotangent can be done in similar way, but this time I did not give you cotangent examples, and I have only given you tangent examples, right? So let's do another pair of tangent example. Okay, so this time I'm going to use slightly different example. Okay, and these two examples will also be from your homework, right? Will also be from your homework, right? And these will be 2 pi over 3. 2 pi over 3, okay? Negative 2 pi over 3, okay? And I wish you guys to observe, okay? Observe. How do we observe that? Okay, and we don't have the curve yet, and of course you can use whatever curve you can get, and it just make sure you know how to read those curves, right? These days it's so easy to get the picture. Sometimes we get the picture, but we don't know how to read it. We don't know what it means, right? So we don't want that. So we want to thoroughly understand these pictures, because these pictures tell us so much information. So we're still digging into the gold mine of definition. Okay, 2 pi over 3. So once again, it's about angle measurement, right? Do we hear that a lot? Angle measurement from standard position, positive 2 pi over 3, counterclockwise. And negative 2 pi over 3 measured counterclockwise. Measured clockwise, right? And the arc lengths, you know, these are the arc lengths. There are also arc lengths involved, right? 2 pi over 3 is the same arc length. Same arc length. Oops. It should be curly. Okay, this is the arc length, right? This is the arc length for the input when we and this is negative 2 pi over 3, really, right? You see, they're all the same idea. And it terminates, right? We have 2 points, right? We have 2 points here. We have another point there. But how do we find the ratio? It's the blue divided by red. That's y over x, right? So the blue divided by red. So this one is going to be root 3 over 2, right? Root 3 over 2 divided by negative half, right? And the next one is negative root 3, okay? So I'm gonna remove those things because it messed up my these two software don't talk to each other. Okay, the next one is negative root 3 over 2 over another negative root 3 over 2. So both are negative, right? Negative divided by negative is a positive, right? Mathematical principle, right? Didn't we learn that, right? So make it 75%, so you can see the negative sign. You can see the negative sign. Okay, you can see the negative sign, right? This is negative root 3 over 2 over negative half. All right, so that's for the second one. Obviously, you know, positive divided by negative, we're going to have negative. Principle number 6, right? Reducing it, we're going to get negative root 3. There you go, right? Because the common denominator is 2. We just multiply 2 times 2, right? 2 over 2, sorry, 2 over 2. The next one is a negative divided by negative, that's positive. So this, once again, is going to be positive root 3, opposite. You see, we see that phenomena of tangent seem to be an odd function once again, right? Different angles. But when you choose the angle properly, you see that phenomena. We see that phenomena, right? So tangent of negative 2 pi over 3 is equals to negative tangent 2 pi over 3, right? So when the inputs are opposite, the output are opposite. How about cotangent, right? You can try cotangent. Go ahead, try them. Cosecant, secant, right? And discover for yourself. But anyway, so we already have a glimpse of what we expect in terms of odd function, even function for the future functions we're going to be working with. Isn't that amazing that we discover these properties? And so we as we look at these unit circle, right, we work so hard to produce, right? We work so hard, right? So we have accumulated so much information, right, in our head, how to look at these quadrants, right? Sometimes, you know, it just gives us different ways of looking at them. And for a cosine case, you can, you know, you can start to think about domain and range for these functions where we are, you know, we have not drawn, because so far we have only done sine, right? And how about for cosine? And how about tangent? How about cotangent, right? So all of these, the method of study is very, very similar. The only difference is the rule of the function is different. The rules of the functions are different. Okay, make sure my grammar is right. But anyway, without further ado, so that's the homework guide on the trig questions. I will continue to give you trig questions and to hopefully provoke you to think and to reflect more on the definition, and you can discover it is such a gold mine to just go to the definition. Actually, definition have told us so many things. We haven't even touched some of the other things yet, and we will get to them, you know, as soon as we can. Okay, so thank you for watching. Okay, see you next time.